converting a complicated network with the many resistors into a single one. Now we consider the mesh analysis. So where we are going to apply the concept of the Kirchhoff's voltage law, we are going to apply, and we are going to find the network circuit elements such as the current or the voltage across the any part of the network. We are going to find out here. So in order to do that one, we are going to consider the simplest network I am going to consider. So let us consider the circuit. We are going to consider this circuit. We are going to consider the circuit consists of the many voltage and the current sources. I'm going to consider the DC network. I will consider. V1. We have the other part of the network. We have. So we're going to consider the other kind of voltage or the current source will be considered here. So this is the resistance R1, R2, R3. So this is R4, the resistance R4, and this is the resistance R5, resistance R6, and the resistance R7 will consider, and this is the other voltage source with the voltage value is equal to the V2. So here what we need to do is here we need to find out the currents in the network. We need to find out, assume that we need to find out the currents in the each mesh here. So this is forms the one mesh here, this forms another mesh, and this will forms other mesh. Let us say the current in this mesh, we are going to call it as a mesh current, we are going to call. So the corresponding it is called as a mesh current analysis you are going to call. So let us say the I3 is having the three meshes is having the three mesh currents are there, I1, I2, and I3. So before starting with the actual performing the mesh analysis, here we are going to make the certain assumptions we are going to make. The first assumptions you are going to assume is, the first assumption is that the current entering negative, leaving positive, we are going to consider as a rise in the voltage we are going to consider. Suppose if the voltage source is there, if the current entering the negative and leaving the positive, you are going to consider as a rise in the voltage you are going to consider. So raise in the voltage, and that will be considered with the positive polarity we are going to consider. And suppose if the current is entering the positive and leaving the negative, we are going to call it as the fall in the voltage, and fall in the voltage, and we are going to consider with the negative sign we are going to consider. This is the first assumption for the voltage source we are going to assume. And the second assumption is that we are going to assume that all mesh currents will flow in the clockwise direction we are going to assume here. So all mesh currents will flow in the clockwise direction we are going to consider here. So clockwise direction we'll consider here. So all the currents we are going to assume as a clockwise direction we'll assume here. And the third assumption is that suppose we have the resistance R6 is there, here the two currents are flowing. Suppose if you are applying the KVL in the mesh 1, then we need to take the mesh 1 current minus the mesh 2 current we need to take here. Suppose if you are applying the KVL in mesh 1, then the current in R6 we need to take as the current. So in the resistance R6, we can assume as it's a difference between the mesh 1 current minus the mesh 2 current we need to assume here. And similarly, if you are applying the KVL in the mesh 2, we are going to assume that as a, so similarly, if you are applying the KVL in the mesh 2, we are going to assume that, so it is I2 minus I1 we are going to assume here. So these are the three assumptions we supposed to make in order to apply the Kirchhoff's voltage law. And as we know that the Kirchhoff voltage law is nothing but the algebraic sum of the in the any closed path, the voltage generated and voltage drop across the resistance will be equal to 0. By default, the voltage sources we are going to take with a positive sign, and drop across the resistance we are going to take with the negative sign we are going to take here. That's one of the assumption of the Kirchhoff's voltage law. And we can based on that one, we can apply the Kirchhoff's voltage law for the mesh 1, mesh 2, and mesh 3 will apply, and will simplify the network will do simplify here. Now with these assumptions, we'll start applying the Kirchhoff's voltage law for the mesh 1, mesh 2, and mesh 3 will apply here. So what we'll do is just I'm going to consider this part of the network we'll consider. So this is a part of the network will be considered here. This part of the network you'll consider. So just I am going to just move it here in order to apply the Kirchhoff's voltage law. Later I will place it back here, there only. So later I will place that one. only we'll place it here. So first, just for applying the KVL, I'm going to consider the network here. So here it is the voltage source is there. So just the voltage source we'll consider here. So this is the mesh current I1, and this is the mesh current I2, and this is the mesh current I3. So we are going to assume, we'll assume the mesh current as I1, I2, and I3 will assume. So now we can see it now. So just I'll apply the mesh current analysis where only we can do apply. So we'll apply the KVL in the mesh 1. So apply KVL in the mesh 1 will apply here. So this is a mesh 1. We are going to apply the KVL in the mesh 1. So as per the assumptions, the current entering negative leading positive, it's a raise in the voltage V1 minus the drop across the resistance R1 is, so it's a R1 into I1 minus in the R6 the two currents are flowing. So since it's a drop across the resistance, it is I1 minus I2, and drop across the R7 is, so minus I1 into R7 is equal to 0. Now we'll segregate we'll send the I1 terms that side and we'll simplify here. So let us take the I1 terms common here. So when you take the I1 terms common, it is R1 plus R6 plus R7 will get here minus, and the I2 terms if we take common here, so I2 is equal to I2 into R6. So this is equal to the V1 will get, call this as equation number 1 here. So this one we can call it as equation number 1. So where we got the expression 1 here. So similarly, let us apply the KVL for mesh 2. Let us apply here. Let us apply the KVL for the mesh 2. So this is the mesh 2 here. So we'll apply the KVL for the mesh 2. So let us start from the R2 here. So since it will drop, the resistance is a minus R2 into I2 and drop across the R4. So since we apply in the loop 2 or the mesh 2, so it is minus R4 into the mesh 2 current minus the mesh 3 current minus the drop across this one is R5 into, so it is I2, and the drop across R6 is, so it's a minus R6 into, so it is I2 minus I1 is equal to 0. Now let us segregate the terms here. So it will become, if you simplify this one, if you multiply, it will become minus R6 into I1 plus I2 into, so R2 plus R4 plus R5 plus R6 will get here minus I4 into R4 will get, so this is equal to 0. Call this as the equation number 2 here. So call this as equation number 2. We can call it here. And now we got the mesh current equation 1 we got here, and equation for the mesh current 2 we got here. Now we'll apply the KVL for the mesh 3 here. So on the mesh 3, let us apply the KVL. So we'll apply the KVL for the mesh 3. So apply KVL for mesh 3. We'll apply the KVL for the mesh 3 will apply here. So let us start from the voltage source. So you're going to make the assumption that the current entering positive of the voltage and leaving the negative, we are going to consider as a drop in the voltage. So it's a minus V2 minus, and the drop across the resistance R3 is, so let us come to the R4 minus R4 into, so it is I3 minus I2, I3 minus I2, and drop across the resistance R3, which will be equal to the minus R3 into, so it is I3 is equal to 0. Let us simplify this one. If you're going to simplify, so this will become equal to the, so it is I3 into R3, so we get minus R4 into I3 into, so it will become plus I3 into R3 plus R4 will get, this is equal to the minus V2 will get. So call this as equation number 3 here. Equation number 3 we can call here. So now let us represent, in order to solve these equations 1 and 2, we'll need to represent this in the matrix format we need to represent here the equation 1, 2, and 3. So in the matrix format, if you're going to represent, so we'll get the expression in the matrix format we'll get here. So that is in the matrix format. So we'll represent. So here the I1 terms are nothing but R1 plus R6 plus R7. These are the I1 terms. These are the R1 plus R6 plus R7, and the I2 terms. The I2 terms are nothing but minus R6 minus R6 is the I2 term. And since we don't have any I3 term in the equation 1, so this is equal to 0. And for the equation 2, it is minus R6 minus R6. And for the I2 terms, it is R2 plus R4 plus R5. So it is R2 plus R4 plus R5. And this one plus R6 is there. And for the I4 terms, it is minus R4. That is for the I3 term. And similarly, for this one, we have 0. And minus I2, it is R4 term. And I3, it is R3 plus R4. So these are the terms we have. And in the equation, we have the mesh current 1. So this is the 3 mesh currents are there, I1, I2, and I3. So when the representing in the matrix format, suppose if the value for the current I3 is not there, we are going to represent with the 0. And similarly, if it is not there, we are going to represent with the 0. And the corresponding voltages we have in the RHS part, it is V1, 0, and minus V2 we have here. We'll represent those equations. So in order to solve this one, we go for the solving the calculator. We can use the equations method in order to find out the 3 unknowns. We can solve that one. Or else we can use the Cramer's rule we can use here. So we can use the Cramer's rule we can use. Cramer's rule we can use. So where we can find out the current for the I1, I2, and I3. So as per the Cramer's rule, it is nothing but so delta 1 divided by delta. So delta 1 is obtained by replacing the first column with the values for the V1, 0, and V2. We can replace here. So similarly, the value for the I2 can be found out by, so it is delta 2 divided by, so delta, and similarly I3 can be found out by, so delta 3 with the delta. So this is delta 2 and this is delta 1. So these terms are not there. So and so this is the delta 1, delta 2, and delta 3 we can find out here. And these currents you're going to get in terms of the amperes will get. So this is how we can apply the Kirchhoff's voltage law, and mesh analysis we can apply in order to find out the mesh current in the circuit diagram we can find out here. In the next session, we'll look into the problems we'll see in the next session.